Alright class, here we are, we're going to start learning how to name the variety of different hydrocarbon derivatives that I introduced to you last class. Okay, pretty much we're going to take everything that we learned about naming compounds with double and triple bonds and now just extend that to compounds with functional groups. Okay. And pretty much everything, like I said, about choosing a parent chain when you have double or triple bonds, and numbering, assigning locants if you have double or triple bonds, applies now if you have functional groups. Okay, so again, remember, you're going to have to be able to identify the different types of functional groups, because that will let you know what type of molecule we're talking about, and therefore the appropriate suffix to pick. And I'm just going to give you a brief rundown of some of the basic rules here when selecting an appropriate parent chain and then assigning locants. And of course, we'll go through this over and over again when we look at each different class of molecule. And so let's look at this example down here in the bottom left-hand corner. Okay. So first and foremost, you would want to identify the functional group. Okay, this thing here is a carbonyl. Okay, it's a carbonyl group and it's in the middle. Okay, so here's your functional group right here. Okay, that's a carbonyl. We've got a carbonyl carbon there, and it's in the middle, right? That carbon there that's forming your carbonyl is attached to two other carbons. That means this thing here is a ketone, right? And your suffix therefore is -one. Again, as with double and triple bonds, you would pick the longest hydrocarbon chain that contained all of your functional groups. In this case, we only have the one functional group, and we only have really one longest chain. We have 4 carbons. Now, in this case, what this example here is illustrating is assigning the numbering. And remember, just like we did before, if we were to have a double or triple bond, first, what takes priority is the presence of this functional group. So what that means is that we want to assign that functional group the lowest possible number possible. Okay? And this will take precedence, like I said, over whether or not we have a double or a triple bond. So we want to make sure we have one of our functional groups having the lowest number possible. Okay? And that's why we're numbering it here from the right, because this will give this carbonyl group a locant of 2. Right? So it's 2O. Right. And remember, we find that information when we in the suffix, like the -one. Right? This tells me it's a ketone. Okay? It's pretty simple to remember. And just like double and triple bonds, we have to say where our functional groups are in the molecule, and hence we need to assign a locant. Okay? All right. In this example, okay, again, now we have 2 functional groups, and the OHs, if you recall, those are hydroxyl groups, which means this thing is an alcohol. Now, depending on how we number in this example, whether we number it the red or the black way, okay, our functional groups, right here are hydroxyl groups, okay, our functional groups are going to be on carbons 2 and carbons 5, so there's no difference there. Okay. Whenever you have a tie like that, right, we need to break that tie. What you would normally do after that, okay, would be to see this, if there were any double or triple bonds. Okay, that doesn't apply to this example. So if there's a tie in terms of assigning locants for the functional groups, you then look at the first difference. Okay, so where are our substituent groups? Okay, so we look at both of these substituents, and either way we number it, again, we're on carbons 3 and 4. And therefore, how do we decide? At that point, how do we break the tie? We use alphabetical. Okay, so this is your propyl group over here, and this is your methyl group. Methyl comes before propyl, so hence we pick the red numbering. Okay, so it would be 3-methyl-4-propyl. Okay, in addition, what I want you to notice that when we write the names of any compound or any hydrocarbon derivative, okay, there's going to be 2 parts to every suffix. Alright, there's going to be the part that tells you about the functional group. Okay, the functional group. And there's going to be the part that tells you about the carbon-carbon bonds. In this example, and even this previous example, okay? This 2,5-diol, this OL suffix tells me that I have hydroxyl groups. This di multiply tells me I have two of them, and they're attached to carbon 2 and 5. Right before my part of my suffix that comes from my functional group, I have the part of the suffix that tells us about our double and triple bonds. Okay, because we can have double and triple bonds as well as functional groups in a molecule. Okay. In this case, right, ane tells me that all my carbon-carbon bonds are single bonds. Let's look at this next example over here. Our longest hydrocarbon chain in this case has 7 carbons. Alright. We have one functional group. There it is. That's an amino group, which means my suffix is amine. Okay. And regardless of how I number it, whether I'm numbering it the red or the black way, my amino group is going to be attached to carbon 4. And when we put that in our suffix, we write 4-amine, because again, we need to say where our functional groups are. Okay. So how do we decide how we're going to number it? Is it the red or going to be the black, since there's no difference with regard to the functional group? And that takes first priority. Remember, you're always going to want to assign that functional group the lowest number. Now, this particular molecule has double bonds in it. So after looking at the functional group, we want to then assign, if possible, the double or triple bonds, okay, the lowest number. So in this case, because we do have double bonds, we're going to use the red numbering, because this will put our double bonds on carbon 1 and carbon 3, as opposed to 4 and 6. Okay, so we're going to start numbering here from the left. Okay, and if there was a tie with the position of the double or triple bonds, then you would want to, again, assign the locants by first difference, looking at where your functional, or where your substituent groups are, I should say. And then again, if there's a tie there, then you go alphabetical. And that's sort of your order. Functional groups, double, triple bonds, first difference by substituent groups, and then alphabetical. Now, remember when we had more than one double or triple bond? We had to add that A at the end of our root when we had more than one double bond. Okay. Now, here's something else for me to throw in there. Okay. When you have only one functional group, observe that normally our suffix for double bonds is ene, right? Our ene ending. But because we only have one functional group, we drop this e. However, if you look at this example here, okay, regardless of whether we have single, double, or triple bonds, if we have more than one functional group, we're now going to include that e in the name. And again, if we compare to this first example here, observe that there is no e because we have only one functional group. Again, I'm just making it more complicated for everybody. So now let's go to our lesson on alcohols and ethers and learn how to name those. And again, we'll use all the rules that we just discussed, okay, and we'll practice them. Okay, so first things first, remember that alcohols contain a hydroxyl group. Okay, and the hydroxyl group is this OH here that's bonded to a carbon. And if we see that present, remember we're going to have an alcohol, and our suffix we're going to use to denote this functional group is OL. Okay. A special type of alcohol we'll see is called phenol. So this is when you have a benzene ring and you have a hydroxyl group attached to the benzene ring. And if that's the case, if this is going to be your parent, if we had smaller branches coming off of here that were less than 6 carbons long, our root and our suffix would be phenol. In this case, we wouldn't have to say, we wouldn't say this. We wouldn't say benzene 1-ol. Okay? Do not use this. Okay? We would not say this, benzene 1-ol. We would simply call it phenol. Okay, so again, you have to look out for this kind of special case. Remember, in these cases, we're using our suffix "all" because it's an alcohol. So right now, don't worry about whether it's primary, secondary, tertiary. We haven't gone through that yet. So let's name the following alcohols. So again, we have one long parent chain. 1, 2, 3, 4, 5, 6. 6 carbons. Okay, 6 carbons. So my root is then going to be hex. Okay. In terms of my carbon-carbon bonds, they're all single bonds, so I'm going to have ane, okay, in my suffix. And I'm not including the E because observe I only have one functional group. Okay, there's my hydroxyl group. So I know I'm going to have all as my suffix, because that's my functional group. Now I don't have any substituents here, but we need to figure out how we're going to number it. And we're going to number it from the right hand side. Because that will give my functional group the lowest number. Okay, if we compare this, okay, between the red and the blue, we're going to pick the blue because it's going to give us the lowest number for our functional groups. This is going to be 3 all, and we're simply going to put that together. Okay, and this is going to be, I'll write out the different, so this is hex, that's my root, and now I've got hexane, AN telling me that I have carbon single bonds, no E because I only have a single functional group, 3 all. So this is hexane 3 all, or hexane 3 all. Okay, next one. 2, 3, 4, 5 carbons. Okay, my root is going to be, this is going to be real simple. My root's going to be pent. Okay, there's my functional group. So my suffix is going to be my functional group. Okay, it's going to be all. I've got carbon-carbon bonds. They're all single bonds. So therefore, I'm going to have ane as my ending. I'm not going to include the E because I only have one. There I have a methyl group. Okay, I'm going to start numbering from the left because it's going to again assign my functional group the lowest number. This is just going to be 2 all. So again, we're just going to put it all together. My methyl group's on carbon 2, so this is simply going to be 2 methyl pent and 2 all. Alright. Next example. There's my carbon, and I select my longest hydrocarbon chain with my alcohol or with my hydroxyl group in it. Here it is. There's my functional group. There's a methyl group. My root is going to be 1, 2, 3, 4, 5. I've got 5 carbons, so my root is pent. 5 C's. Now, I've got double bonds. Okay? Which means my part of my suffix is going to be different. Okay, so I've got carbon-carbon double bonds, which means my suffix is going to be en. And again, I'm not putting the E there for the ene because I only have one functional group. Okay? And my functional group is going to be all. Right. Now we have to figure out how we're going to number this. Again, I want to assign that hydroxyl group the lowest number, so I'm going to start from the right hand side there. And that will give my functional group the lowest number. And that's what I want. So now I know the position of my functional groups is going to be 1 all. But now I have 2 double bonds, So it's gonna be a diene. Okay, and those double bonds are on carbons 1 and carbons 3. Okay, so it's going to be 1,3-diene, and we're going to have a 3-methyl. Okay, so again, let's put that all together. So we're going to get, let me try to color coordinate this as best as I can, okay? 3-methyl. Now we have 2 double bonds. Remember, when we have more than one double or triple bond, we need to add that A to my root. So this is penta. Penta 1,3-diene without the E, 1-ol. 3-methyl-penta 1,3-diene 1-ol. Yeah, complex. We're getting there. Okay, but if you can understand this basic concept, then you're good for naming most of these hydrocarbon derivatives. Let's move on to example 2. Again, we're going to want to pick the longest hydrocarbon chain with all of our functional groups. Okay, and here's our longest hydrocarbon chain. 3, 4. Our parent is actually going to be a 4-carbon chain. Okay. Now, even though we've got this benzene ring here, and it's longer, it's got 6 carbons in it, it doesn't have the functional groups attached to it. So it's not the parent. Okay. This chain is, because it contains our 2 functional groups. Okay. There are our functional groups right there, which makes this benzene ring, okay, a substituent, okay? And because it's directly attached to my parent chain, this is a phenyl group. And now we're going to number our parent chain, and again I want to assign these functional groups the lowest number. We want to give those the lowest number instead of our triple bonds, if we can. In this case we can. We're going to start numbering from the end, 1, 2, 3, 4, okay, and that will give our functional groups the lowest number. Again, our root here, since I have 4, is going to be bute. Okay, I only have 1 triple bond, so I don't need to add that A. Okay, I've got a carbon triple bond starting on carbon 3, so I'm going to have 3-ine. Now, because I have more than one functional group, I'm going to include that E this time around. Okay, and then my functional group, I have a 1,2-di, and the suffix for the hydroxyl groups are OL. And then we have a phenyl group attached to carbon 4. So you put that all together, and you're going to have 4-phenyl bute bute 3-ine 1,2-diol. 4-phenyl bute 3-ine 1,2-diol. Yeah, that's not. Well, I mean, it looks complicated, but as long as you break everything down into the root and the suffix, you should be okay. Alright. Let's do another example. Last example. So again, if I could draw the longest hydrocarbon chain would be from here, from this top right-hand corner all the way around to this bottom right-hand corner over here. However, that hydrocarbon chain does not contain my functional group. Just remember, when we pick the parent chain, we need to pick the parent chain that includes all of your functional groups. And so to do that, I will need to start on this end. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So going up would give me the longer parent chain. Okay. There's my hydroxyl group. Okay. Over here I have a fluoro, and over here, right, I've got 1, 2, 3 carbons attached to the parent chain at the end. This is a propyl group, okay? when I start numbering, I'm going to start numbering to give my hydroxyl group the lowest number, and that's going to happen here on the left-hand side. 1, 2, 3, 4, 5, 6, 7. Okay, I've got all carbon-carbon single bonds. Okay. So my part of my suffix is going to be ene. So let's just put this all together right now. I've got a 4 fluoro and a 3 propyl. So we're still listing our substituent groups in alphabetical order. So this is going to be 4 fluoro, 3 propyl. I've got, okay, so that's my prefix. Now I'm going to put my root for 7. That's hept. I've got all single bonds, so an, heptane. But I'm not going to include the E because I only have one functional group. Now I'm going to throw in the rest of my suffix, which is 2-ol. This is 4 fluoro, 3 propyl, heptane, 2-ol. Alright. Drawing is also just as easy with alcohols. Again, let's break this down, okay, into different parts. So I look to the right in my suffix. So look, I have 2, 3, 4 triol. So OL tells me I have hydroxyl groups. I have an OH, but I have 3 of them. Right? Triol. I've got 3 hydroxyl groups, okay, attached to carbons 2, 3, 4 of my parent chain. Now I also have, okay, look what else I have here in my suffix. 1, 4 diene. Ene. That tells me I have carbon-carbon double bonds. And di, that means I have 2 sets of double bonds. Okay? And then here's my root. Here's my penta. Tells me there are 5 carbons in my root. So let's draw, and I've got no prefix, so I don't have any substituents. There's no prefix here. So let me just draw this. There's 1, 2, 3, 4, and 5. That's number 1, 2, 3, 4, and 5. My double bonds are attached to carbons 1. So there's 1 double bond, and then carbon 4. There's my other double bond. I have 3 functional groups, 3 hydroxyl groups at carbons 2, 3, and 4. So let's add those. 1, 2, and 3. So there we go. All done. Again, let's look over here. So we look to the right. I've got all, but observe what comes before it. Phenol. So all, you're like, oh look, there's my suffix phen. What kind of root is that? Okay. It isn't. Technically, this whole thing is your root now. Remember I gave you that special example of phenol? Okay, that's your benzene ring with 1 hydroxyl group. Okay, and we're always going to assume that a hydroxyl group is always on carbon 1 in phenol. Okay, so in phenol, your OH is always on carbon 1. Okay? And now I have to look at here's my prefix. So what do I have? I've got propyl, but I also have, so that means 3 carbons, but observe I have cyclopropyl. So that means I've got a 3 carbon ring. Okay, and I have 2 of them. I have 2,6-dicyclo, so I've got 2 times this stuff. So let's start off by drawing my phenol. Means there's a benzene ring. Okay. So here's 1, 2, 3, 6. And by convention, we tend to draw the OH at the top, as that's carbon 1. So let's just number this. That's 1. It doesn't matter which way you go at this point. Okay, 1, 2, 3, 4, 5, and 6. I'm now going to add my 2 substituents on my second carbon. Remember, our cyclopropyl groups look like triangles. And then here we are on carbon 6. Right. There we go. That's 2,6-dicyclopropylphenol. Okay. So that ends our little bit on alcohols. Now let's move on to ethers. Okay, so ethers are a little bit different. We talk about these functional groups. Okay, remember, let's just look at, and we'll talk about this in class, what our ether functional group looks like. It's pretty much we've got two carbon chains being connected by this oxygen. Okay, and unlike our other functional groups, okay, we're actually going to include these ether groups, these alkoxy groups, in our prefix. Okay, and we're going to use oxy in the name. Okay. Now we'll look at different examples. Okay, so let's continue to scroll down. Okay, to naming and drawing ethers. Now, when we look at naming ethers, okay, now let's look at this example over here. Observe, here's your parent chain, okay? Here's your parent chain. It's got 6 carbons, okay? And here we have a substituent. Here's our methyl group, okay? But observe, we also have this. Okay, and this is what we would call our alkoxy group. It's not an alkyl group, right? It's not a smaller carbon chain directly attached to the parent. It's an alkoxy group because it's a carbon chain attached to our parent chain via, observe right here, our oxygen, okay? There's our oxygen right there, and that's what makes this an alkoxy group. Now we treat this alkoxy group as a substituent, okay? So we're going to treat as a substituent, as if it was a side chain. Alright, the only difference is now when we name the substituent group. Okay, so observe, we have a methyl group, it's 1 carbon directly attached to our parent. If we had an alkoxy group with 1 carbon, so we've got that 1 carbon attached via this oxygen to my parent chain, we would drop the YL ending and add the OXY ending. So instead of a methyl group, we would say methoxy. In this example up here, again, we've got 3 carbons, so we would choose prop, and it wouldn't be propyl. If it was a propyl group, these 3 carbons would be directly attached to your parent chain, but instead they're attached through this oxygen, so we call it a propoxy group. Okay. All the other rules I told you about substituents applies here. Okay, that we just name ethers as if part of the molecule was a substituent. Alright? We would still find the longest hydrocarbon chain possible, and then identify any of our substituent groups, and some of those might be, like I said, alkoxy groups. Now I want you to observe this point right here. If we don't have any other functional groups present, okay, and when we do number the chain, we want to give this alkoxy group the lowest number possible. So that's a little bit different from other substituent groups. Okay? Key is if no other functional groups are present, okay? Only in this example, then do we want to give the alkoxy group the lowest number. Otherwise, those other functional groups get the lowest numbering possible, okay? So let's look at some examples. Let's name the following compounds. Okay, let's identify the longest parent chain here. Okay. Here it is. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6 carbons. Okay, so I've got a 6 carbon chain. Okay, that means my root is going to be hex. Okay. Here's my substituent group, okay, right here. That has 2 carbons, but we're also going to include this oxygen, okay? So with 2 carbons, if those 2 carbons were directly attached to my parent chain, we'd call it an ethyl group, but because they're attached via this oxygen, this becomes an ethoxy group. Again, we're going to want to assign numbering to give I don't have any double or triple bonds here or any other functional groups. We want to give that alkoxy group the lowest number possible, and that's only going to happen if we start numbering over here from the right. Okay, this is all single bonds, carbon-carbon single bonds, so my suffix here will be ene. I've got no other functional groups. Okay, so we name this thing together. Remember, we're going to treat this as a substituent. So this is 3-ethoxy. So this is simply 3-ethoxyhexane. Okay, next example. Observe, oh look, I have a functional group here. Functional group. So when I pick the parent chain, now that I have a functional group, again, I want to pick the parent chain that has this functional group in it. Okay, so the longest hydrocarbon chain that is 1, 2, 3, 4, and 5. That means this whole thing here is going to be a substituent, okay? And it's got how many carbons? 1, 2, 3. So if I had a 3-carbon substituent, that would be propyl, but because it's attached to the parent chain via this oxygen here, this becomes propoxy. Now let's number. When we assign the numbering, even though we have this alkoxy group, we want to give this functional group the lowest number, and that only happens if we start numbering from the right. So your root here, I've got 5 carbons, so pent. All I've got are carbon-carbon single bonds, so I'm going to have as part of my suffix ane, but no e here, okay, because I only have one functional group. And then my functional group is going to be 2, and because I have my hydroxyl group, the appropriate suffix would be all. 2-all. And then I have my 4-propoxy. So I'm going to put that all together. We're going to treat this as, remember, as a substituent group, so we include it in the prefix. So this is simply 4-propoxy pentane 2-all. Alright. Next example. Oh, good gracious, what's this that I've done? Alright, let's name this beast. Again, I want to identify the longest hydrocarbon chain. All I have are these alkoxy groups. I don't have any other functional groups, okay? I'm going to find the longest hydrocarbon chain then. That includes this double bond. Again, treat this alkoxy group as a substituent, okay? So here I have this ring structure, but it's attached via the oxygen, okay? So what are these? Look, I've got a 6-carbon ring. That means it's hex, but because it's in a ring, it's cyclohex. And if that was directly attached to the parent chain, it would be cyclohexyl, but it's cyclohexoxy. That's a tongue twister. In my root here, I have how many carbons? 1, 2, 3, 4, 5, 6, 7, 8. So my root is going to be oct. I do have a double bond there. So that means I'm going to have ene. But again, no e because I have... oh no, in this case I don't have a functional group, so we're going to include the e. Now when we assign numbering, though, again, which way are we going to number it? Okay, treat this as a substituent group, but we have a double bond, which means the presence of the double bond takes precedence over the position of our substituent. So we want to give this double bond the lowest number possible, because we don't have any other functional groups. Okay, so we're going to start numbering from the left-hand side, because this will give my double bond the lowest number possible, okay? That's going to make this 3-ene. And my functional groups are going to be on carbons 3 and 7. And I have 2 of them, so I have to include that multiplier die. I have no other functional group besides the triple bond. Okay, that's going to be found in the suffix. We're going to put this all together, so this is going to be 3,7 dicyclohexyl not hexyl, hexoxy. Let's make that correction now. Dicyclohexoxy. Oct 3E. Alright. Let's move on. Let's draw some structures of ethers. Then we want to identify the different parts of your molecule. So I start from the right. I've got 3E. Okay, that's my suffix right there. That tells me I've got a carbon-carbon double bond right on the third carbon. Hex. I don't have anything right before it. That's a cyclo, so I have a 6-carbon chain. And here's my prefix. Look, 2,5-dimethoxy. Methoxy. That means I've got a carbon, one carbon. Okay, a one-carbon thing attached via an oxygen. Okay, and I've got 2 of those. So let me start drawing this out. So hex, I've got 3 carbons. 6. 1, 2, 3, 4, 5, 6. Let's just number this. Let's put in my double bond on the third carbon between carbons 3 and 4. And now I have to add these methoxy groups. So remember, I'm attaching this one carbon via an oxygen. So on carbons 2, there's my oxygen, and carbons 5, there's my oxygen. I'm going to attach one carbon to that now. There's my one carbon. There's my one carbon. So this thing here is 2,5-dimethoxy X3E. Let's move over here. You give yourself lots of space in this one, okay? 1,2,5,6 tetraphenoxycyclooctane. That seems very complicated. Let's break it down. So start at the end. I don't see any alls or oic acids. All I see is ane. Okay, that tells me I have carbon-carbon single bonds. Pretty straightforward. Okay, pretty straightforward suffix. Oct, there's my root. Oct. But observe, right before my oct I have cyclo. So my root is actually psycho-oct. That means I have an 8-carbon ring as my parent. Okay. And this whole thing now is my prefix. So 1, 2, 5, 6, tetra. Tetra is my multiplier. So this here, phenoxy. Phenoxy. What would that look like if I didn't have the oxy? That would be like phenyl. That means I have a benzene ring. Okay, attached via an oxygen. That means it's phenoxy. If it was phenyl, that benzene ring would be directly attached to your parent chain. Okay, but I have 4 of those. Right? Times 4. Right, so let's draw this out. So your 8-carbon ring, remember, looks like a stop sign. 1, 2, 3, 4, 6. Okay, and it doesn't matter how you number this, because it's a ring. And now we're going to add these phenoxy groups. The carbons 1 and 2. So remember, we're going to attach that benzene ring via an oxygen. We're going to do the same to carbons 5. There are your phenoxy groups. So 1, 2, 5, 6 tetraphenoxy cyclooctane. Right, that ends the lesson on alcohols, or the nomenclature of alcohols and ethers. Okay.